2 thumbs up. Great. Thank you. 3. Do you guys need any help with anything?
We just have to
yeah, if you just fill out the form quickly and just ask for your name, username, and email, pretty much. Good. Okay, sweet. Let's get going. So we'll start off with some quick tools and tips that you will use in competitive programming all the time. So first off, use pencil and paper. I know it's a lot of people's first instinct to jump right into an editor and start coding and trying to just get down an answer to the problem. You're worried about how fast you can do the problems in. But the most important step is to think about your solution to a problem before you start even coding. A lot of times just on pencil and paper, you'll be able to figure out what the trick to a problem is, what they're really asking, before you even write a single line of code. So it's a great tool to get you thinking about it in the right way. We also use C++ in our workshops, and we recommend it as a language for competitive programming because it's very fast, it's very low level. It offers a lot of robustness in its standard library, so it has all the different data structures and algorithms you might need for a problem. And the majority of UCLA courses often use C++ as well, so it's a good one to practice here. You can use languages like Java and Python for submission too, or a number of other ones, but they are probably not as best served for the purpose. Any sort of editor or compiler that you got set up on your computer is good. Hopefully you have some experience using either Visual Studio or Xcode. Those are great development environments. But if you don't, there's also the website repl.it, which is good for just writing a quick program and testing it. It can run in C++ and be used for competitive programming perfectly fine. So next up, solving a problem. The general process when you open a problem up on Kattis is that you'll get this page on the left here where you'll see a bunch of information about the problem and some sample test cases and a submission button. So your first step is just to read the problem, figure out what's going on, start thinking about how you want to solve it, maybe some pencil and paper work. Next up, you want to code your solution, type it up, test it, make sure that you're checking for all the different edge cases, all the possible inputs, making sure your program works robustly. And then once you think that you have a good program that should work, submit it to the judge on Kattis, and it will tell you what you did wrong, and you can go back and debug and try to fix the problems, or it'll tell you that you got right. So for some example problems today, please go to this link to join the contest. Once you're at the link, just click the gray join the contest button, and you'll be in, and then go to our first problem. And let me know once you all see problem A, Peragrams, up on your screen. Okay, sweet. Is everybody able to join? Good, good. Wait a couple more seconds. Yes, and if you just click on the A, you can open up the first example problem. If you want to start reading through the problem statement, that sounds good too. Okay, for the sake of time, we're going to keep going. So when you see a problem like this, there's typically 4 steps you want to go through. So you want to break it down into reading the problem, understanding it, solving the problem, devising your solution, figuring out what you're going to code, and then implementing that code, making sure you test it for all your test cases, and then debugging. So for this problem, Peragrams, you can see the problem statement is the top part, and the part that says task. The input and output description is given beneath that, along with some sample test cases, an input and the output that you should get from that input. And then on the top right is the details and submit button. And so hopefully you guys have gotten a chance to quickly read through this problem. Basically, a paragram is a palindrome of an anagram or vice versa. So any collection of words that when moved around, the order shifted in an anagram-like way, it can form a palindrome. And that's pretty much the gist. So we're looking for, given a string as input, what is the minimum number of characters that you have to remove in order to form a paragram. So hopefully you probably already have some ideas about how to go about solving this, but just to help you out, we're going to go through every step very clearly and see the thought process. So an anagram is a word formed by rearranging the letters of another, such as cinema formed from Iceman. A palindrome is a word read the same backwards as forward, like madam or nurse's run or race car. And a paragram is a combination of the two. So for example, AAB would be a paragram because it can be rearranged as an anagram into ABA, which is a palindrome. It's read the same forward and backwards, but a string like AB could not do so because it has 2 different letters. There's no way to rearrange it, so it's palindrome. And so you'd have to remove a letter to make it a paragram. So we look at the sample input and outputs that the problem has given us to help determine what we're supposed to do. So if we go through the first sample input, we can see that the string ABC cannot be formed into a paragram. So we try removing a letter, and let's say we remove the letter B, we get the string AC. This cannot be formed into a paragram either. And so we have to remove another letter. And so we can see that for a word like this, ABC, you have to remove 2 letters, and that's why the output is 2 in order to form a paragram. Pretty straightforward. So now, instead of looking at the second test case, let's look at our own test case as an example, trying to figure out what we're trying to identify with this problem. So let's start with a palindrome, such as pull up, and let's turn it into a random anagram of itself, such as old pup here, and see what can we notice about the letters in this word. Does anybody have any ideas? Yes? There's 2 of each of them, yes. So every letter has a pair. And this is important because that means that for every letter in the start of the word, there's one in the other side of the word, a matching pair that allows it to be a palindrome. And now if we look at another palindrome in a word like tenant, we see that not necessarily every single letter has to have a pair. In the word tenant, there can be 1 letter, the N in the middle, which is not matched up, but that's okay because you can place it in the middle and it still will result in a palindrome. So we see that every letter has a pair except for 1, which can be the one odd one out. So we're basically looking to remove all the instances of letters that are odd, except for 1. So more literally, what we're going to do to solve this problem is count the number of occurrences of each letter. This can be done using an array of 26 integers, where each index in the array represents a different letter in the alphabet. You ignore all the letters, which is an even number of occurrences, and ignore the first letter with an odd number of occurrences. Then for all the remaining letters, you would delete exactly 1 character from that letter count to create your paragram. And so if you keep track of the total number of characters that you need to delete in order to make the string a paragram, then you can return that value as your answer. So now we need to code our solution. For Kattis, you must create a full program, not just a function like you would for LeetCode, for example. So you need to have your include statements, you're using namespace std and your int main. You need to make it fully executable. And you can use the hashtag include for bit/stdc++.h if you're on Windows. That will include all of the basic things that you need for a problem like this. Or you can just use regular include statements if you're on Xcode or Mac, such as include IOStream and string and vector. Today we'll pretty much only be using IOStream and string. And when you're done coding a solution, go to submit button. You can either directly upload a file to be judged by the judge, or switch to the editor and just directly paste in your code and then click submit, and it will tell you your results. So let's get started. You can run your own code locally on your machine, check out the test cases. Even if you pass the 2 example test cases, that doesn't necessarily mean that your program will be accepted, because there are a bunch of secret test cases which will test your program more thoroughly. So make sure that your program works for all possible inputs, consider every case. And you're welcome to use this starter code on the slide here to get you started. You can change as much of it as you want, but it's a good place to begin just for getting started writing the real meat of the solution to the problem. Hopefully you understand what you're supposed to be doing, and I'll give you guys a couple minutes to give it a try. And if you think you got a solution, you can try to submit it in the problem on Kattis and see what it says.
Oh, wait, I used the very thing.
Take about 1 more minute to try to solve this, and then we'll give you a solution sample code, so no rush. Okay, so sorry to interrupt you all in the middle of your coding. I know it's very exciting, but we'll give you a sample solution to the problem. You probably are on the right track to getting to the right answer. So let's just give you a compact version and we'll go through it quickly and explain what's going on. So if you haven't completed your solution yet, after I'm explaining this, if you want to try copy pasting this code into Kattis and submitting it just to see what that would look like, you can go ahead. But basically the way that I implemented this is I created the count array to keep track of all of the different letters and initialize it to 0. So we can start each value at 0. Then for each character in our starting string, which is represented by s.length, we add si minus a. We add 1 to position si minus a of our count array. Now what this is doing is si takes the ith character in the string, and then by subtracting the character a from it, we turn the character ASCII value of the letter into an integer that starts at 0. So we know that as input, we're given only lowercase letters. So by just subtracting lowercase a, we automatically turn all the ASCII values of characters into integers that we can use to index into our count array very efficiently without having to directly identify what the letter is. Just by subtracting a, you can automatically put it in the right position, and then you just increment the count of that position by 1 for each time that you see that letter. So this is a quick way just to go through and keep a count of all the different letters. Then I create the variable numodd to count the number of odd numbers in our array. And we iterate through the whole array. And if at any position, the modulus by 2 returns 1, aka the number is odd, we add 1 to our numodd count. And then as an answer, if you haven't seen this notation with the question mark and the colon before, this is basically just a condensed if statement. And so by checking if numodd is equal to 0, we use the question mark to ask if that's true or not. And if it is, then we do the thing after the question mark, which is 0. And if it's not, then we do the thing after the colon, which is numodd minus 1. Now what this does is that if you have 0 odd numbers, every number is even, you can return 0. It's already paragram. You don't need to remove any letters. If there's 1 odd number, that's also fine. Then we return 1 minus 1, which is still 0. No need to remove any letters. And then for any odd number of letters past that, we simply remove 1 from each, effectively returning the number of odd numbers minus 1. And then we just see out our answer, and that's it. Does anybody have any questions about any part of the code, anything nitpicky at all? A map? A map is good, and it's definitely good for problems that use strings and where you're trying to identify the number of counts maybe that you're seeing of each string. But for this problem, it's honestly more efficient just to index directly into the array in this way, because an array has a faster access efficiency than even a map does. So because we can just use the index value of the characters directly, this way is actually quicker.
Yeah, although it is worth noting that whether or not you use a map or an array, its constant lookup time is the higher factor for map. And really, I think basically in practice, it's the asymptotic complexity that really only matters. These aspect instruments are really large, and worst case test cases will end up causing your code to exceed the time limit. So maps definitely also a good solution. Yeah,
map will work great, but this method works fine too. So anything that you can come up with is totally a-okay. Okay, is there no other questions? Moving on. So assuming that maybe you implemented your solution incorrectly and you're not passing one of the test cases, here are some tips for debugging. If you get a correct verdict, which maybe you've already just tried, you'll get the series of green check marks and the status accepted, which means you passed the problem. Great job. However, if you get any of these error messages on the left here, then this is what's wrong with your solution. AC means accepted, you're good. WA means a wrong answer, which means that you didn't pass one of the test cases explicitly, which just means that they probably threw a weird input at you that your program wasn't ready to handle, and it's one of the edge cases that your program can't deal with yet. So you should probably go back and check, make sure that your looking at cases like 0 and really large numbers and really weird numbers, just testing everything, making sure that you're considering every part of the problem. If you get a time limit exceeded error, it means your solution was too slow, which a lot of times means that you went for the brute force method, or the, often just for loop method. You just iterated through everything and just didn't think about efficiency, tried to implement it quickly rather than well, and it took too long. So you need to think of a solution that is more efficient, uses a different kind of algorithm that can get the problem done in a faster time complexity, as Ryan was talking about. If you get a compiler error, you should probably be able to catch that before you submit to Kattis, because you can check that on your own computer. Same with the runtime error, although it is always possible. If you get an output limit exceeded or a memory limit exceeded, you're probably running into a weird problem. I don't think we'll run into that in this workshop at least. So let's move on for now. Kind of talked about these, but if you get a runtime error, you might also be accessing memory that's you're not allowed to, such as indexes of an array or a vector outside of its defined length. Maybe you're dividing by 0 somewhere accidentally, which could happen if you're dividing by a variable, which gets set to different values. If you have a time limit error, you might also just be caught in an infinite loop somewhere. So make sure that you're debugging and checking that everything is running as you expect it. And if you get a wrong answer, as I said, check for edge cases, things out of the ordinary. So in summary, we want to read through the problem, devise our solution, code it, implement it as thoroughly as we can, and then debug to figure out what exactly is going wrong with it. So now let's move on to our second example problem. If you want to go back to the contest and open up example problem B, lost lineup, I will just read it out quickly. Oh, do you want to teach this one?
Oh, no, you can go. Oh, sure. Okay. Cool.
Raya will teach example problem B.
Yeah. All right. I guess I'm going to give you a minute to read this yourself, either on the slide or in the contest, and then I will read it to you and we will work on it together. Oh, yes. Skip 60 seconds out of me. Awesome. So it's been about a minute. Just for the sake of time, I'm going to read this. And just so you guys know, by the way, when we stop you after like a certain amount of time, it's not because that's the amount of time it's supposed to take you to do anything. It's just because we have our own time limit. But like, don't feel any like type of way about it. But okay, I'm going to read this. So Jimmy and his friends were all standing in a lineup for ice cream when a huge, assumedly like gale force wind gust blew them all around. And the friends want to keep things fair, make sure that everyone gets their ice cream in the order that they started with, but the friends don't remember the order. But each of them remember exactly how many people were between them and Jimmy being the person who's first in line. And so the problem asks, can you help him and his friends remember the order? The input that they're going to give you is a single integer, n, on the first line, where n is between 1 and 100 inclusive, which would be the number of people in line. And then the second line, this part for me was the tricky part, contains n-1 space separated integers, where each integer will be between 0 and n-2, and each integer represents the number of people between the i+1th person and Jimmy. Jimmy, again, being the first person in the lineup. And then the output's just going to be a single line, n integers, which would be the people in order of how they lined up for the ice cream. The part about this that really confused me, and so I'm going to take a second to go over it, was the second line contains the i+1th person and Jimmy. What is that? basically, you just have to think of it as like two index, basically. So we see here, we have the ith person, right? And so person 1, then the number here is 1, so it's going to be person I plus 1. So person 2 has one person between them and Jimmy. Hopefully that's making sense. And so you can see here, number 2 is also the number 2. And so we see person 2 plus 1. So person 3 is going to have 2 people between them and Jimmy. Just to see if this is making sense to you guys, can you tell me, I mean, I guess it's on the slide as well, but how many people are between Jimmy and person 4? Make sense? Maybe I'll go through it again. Okay. Don't worry about it. It's really confusing. It was confusing to me too. Okay. So you see these numbers here in the second row, 1, 2, and 0. So we're looking at them. 1 would be the first number. So that's if the index I is equal to 1. 2 is going to be the second number. So I is equal to 2. And 0 is going to be the third number, where I is equal to 3, right? And so when it says that this number represents the person between the I plus 1th person and Jimmy, we can look at 1, that's at index 1. And so it's going to be I plus 1. So 1 plus 1, that's person 2. So person 2 has one person between them and Jimmy. And we can see actually on the next slide what that looks like. So we can see person 2, if you see the big circle with the 2 in it. And then Jimmy's the blue circle with the 1. There's one person, person 4, in between person 2 and Jimmy. Does that make more sense? Okay, yay. And so we can see also why, like this right here is the sample output too. We can see why this output works. The problem, it says it guarantees that there's going to be one unique solution. And here it is. We can see here, person 2 is one person between them and Jimmy. Person 3 has 2 people, people 2 and 4, between them and Jimmy, and person 4 has 0 people. Person 4 is just right behind Jimmy. And so the whole concept of this problem is we have to ask if there are k people between Jimmy and some person, what is that person's position in line? So like if I'm in line and I know there's 2 people in front of, in between me and Jimmy, where must I necessarily be in this line? Yes, perfect. That's fantastic. So yes, if there are k people between Jimmy and someone, and this person is necessarily at position k plus 2, because there's k people, and then there's Jimmy, and there's you, so that is k plus 2. Perfect. And so knowing that that is the solution, we're going to give you a second to try and code it up yourself. I guess what, like 4 minutes? That may or may not be enough time, but we do have to move on. But here's some starter code on the right to get you started. And then after that, we're going to walk through the solution. That's on the next slide. So I guess if you don't want it ruined, don't look on the next slide. But if you do, do.
And if you have any questions, any confusion, always feel free to ask. We're all here to help.
Oh, yeah. Let me know. Oh, awesome. Another minute and then 4 minutes. Yeah, that sounds good. So,
It can take about 1 more minute to work on this. Okay, sweet, thank you. Everybody, this is our ACM ICPC president, Robert. Yeah.
Hope you guys are all enjoying yourself. They're here, so if you have any questions, please utilize them. They're all very capable.
Bye, Robert. Thanks for coming.
I'm taking 20 extra seconds because we're okay.
Yeah. So. So use this C and statement, then the variable you want. The C just pull the next integer and we'll stop with space. So because there's space separated integers, if you're unfolding code for each integer, and then you see into an array that will be for each position of the array, then you'll be able to save the values. So we're using C. Yeah, CM like takes it and see how it works.
Okay, cool. I guess we'll go over the solution that we have on the slides here. But great job working. And I'm sorry to have to stop you. Okay, hang on a minute. Alrighty, so hopefully you can see on the slides the extra lines of code that we have in there. It's 5 extra lines. And I'll go through it with you. So basically we have, an integer n, declare it, and then we use cin to read it in. And then we also declare this answer array with n entries. And then we declare the first space to be 1 because Jimmy is always going to be there. So he's always going to be the first person there. And then all we have to do is take in, every time we take in like an integer from the second row, then we're going to put it into the k plus.
Oh, I just had a question about code. What doesn't like the implementation here use like a variable length array? And then won't that throw an error because I don't know, C++ standard doesn't use or doesn't like variable length arrays.
Variable length array.
Yeah, wrong, but I thought this like when you make this and or like array of this and array, I thought that would be like a variable length array.
I believe since n will be like, since we get n, we have n at that point, and you know what n is at that point, that it won't throw an error. But
I think like at compile time, your program's not going to know the length of the array, but during runtime, it will be defined. Like it won't be able to reach that point in the program without knowing the value of n. So it will always be able to define a set length for the array. So even though compile time will be short during runtime, it's not going to cause any errors. So,
Yeah, that was a great explanation.
At the higher level is to define a max n as a constant, global constant, and then define all arrays you can use without max n in the global scope instead of it. So it's okay, so there would be absolute problems.
so if you're ever worried about it, you can just do that.
Fantastic. Great. That's a great question. Yeah, sorry. And so then all you have to do is then you take in and you put this person K, at the K plus 2 space in the array, and you give them the value I plus 1, which is exactly what we talked about. And you can see here we have a -1 just to deal with the indexing, because the problem gives us, it was one index, sorry, like 1, 2, 3. Whereas in C++, arrays are 0 indexed. So I'm just subtracting a 1 here. And you could actually just do like K plus 1, but I put the K plus 2 minus 1 to make it more explicit. Hopefully that makes sense. Any questions about this? Okay, if not, we'll move on, but feel free to think about it and then come after with questions if you have any.
That. Oh yeah, this is our other beginner track officer for the quarter. This is Tony. Tony, you want to introduce yourself? Say your name, major, and favorite ice cream.
I'm Tony, third year CS major. CS was the final. Yeah.
What's your favorite ice cream?
Favorite ice cream flavor? Coffee.
Yes. Okay, so now let's get into our third example problem. If you go to the contest, then go to example problem C, boss battle. This is personally my favorite example problem. I'm excited. I'm just going to read out the description so we can get through it. You are stuck at a boss level of your favorite video game. The boss battle happens in a circular room with n indestructible pillars arranged evenly around the room. The boss hides behind an unknown pillar. Then the two of you proceed in turns. First, in your turn, you can throw a bomb past one of the pillars. The bomb will defeat the boss if it is behind that pillar or either of the adjacent pillars. Next, if the boss is not defeated, it may either stay where it is or use its turn to move to a pillar that is adjacent to its current position, picking randomly one side or the other. With the smoke of the explosion, you cannot see this movement. The last time you tried to beat the boss, you failed because you ran out of bombs. This time, you want to gather enough bombs to make sure that whatever the boss does, you will be able to beat it, certainly. What is the minimum number of bombs you need in order to defeat the boss in the worst possible case? And figure 1 is this, referencing this right here. So our input is the number of pillars n, and all we need to give as output is the number of bombs needed to beat the boss. So here's an example of n equals 4, where there are 4 pillars in the room. And you can see that when you throw your first bomb at any position, you eliminate those 3 pillars. Then on the next turn, assuming the worst case that the boss was on the one pillar that you didn't blow up, he can move to either the top or the bottom pillar. So neither of those pillars, you can be sure he is no longer behind. So you mark them as white, and then you can throw your last bomb on the right side to eliminate all 3 at once, ensuring that you definitely have to defeat the boss. Now for the hints for the problem, another sample input that may be easier work with than the second sample input that they give us is n equals 5. The solution is 3 bombs necessary to beat that. And once you figure out a strategy for why that is the case for n equals 5, you can try out n equals 6, n equals 7, and also think about the edge cases for this problem, maybe values of n where your strategy doesn't hold. Think about what happens when n is really small. And now you can take a moment and give it a try for yourself. Another hint is that this problem may be a lot simpler to implement a solution for than you think. So I'll give you guys another 3 or 4 minutes to work on that. And then we'll go through the way that we came about devising a solution. Okay, about 30 more seconds maybe. Last ideas you have. Okay, great work. Now we're going to go through the way that we came about devising a solution for this problem. So we're going to walk through an example of n equals 6 just to highlight our ideology for this problem. So imagine that you're given an empty playing field, 6 pillars. You throw your first bomb at any position, so you throw it in the top left here. You eliminate those 3 positions on your first turn. Then on the boss's next turn, they could be in any of those 3 positions. So since you have to assume the worst case, you have to eliminate the 2 X's on the edge of the bomb blast radius that you just threw, because the boss has the capability to move into one of those positions on his turn, into either of those positions on his turn. So you have to assume that neither of them are safe and that the boss can be behind either of them. And so within the first turn of you and the boss, what you have done essentially is eliminate 1 position. There's a guarantee that the boss is not behind the position where you originally threw the bomb, because he can't move 2 squares in 1 turn. He can only move 1. So you know that you eliminated 1 position with 1 bomb. Now on your second turn, you can start the game off knowing that he's not behind that pillar. So you can throw your bomb specifically in a place that will aid you. For example, if you threw it at the top here, you're overlapping with the square that you've already eliminated. And so it's not probably the best solution. Maybe a better place to throw it would be 1 square to the right, for example. And you can see that if you do this, now you have created a continuous chain of places that you have eliminated. And now there's only 2 positions where the boss could be on your second turn. And this turn, the boss can move into either those edge blast radius positions again. So you cannot call those positions safe. But all in all, at the end of your second turn, you have eliminated for sure 2 positions on the graph. You know that those 2 middle X's within the 4 are safe now. The boss is definitely not there. And so you can see now that on your third turn, you do the same thing again. You create this chain of eliminated pillars. And now the boss only has 1 position in the worst case that they could be in. And so they can move either up or down. And now there's 3 pillars remaining that you haven't yet guaranteed to be safe or boss free. But you can use your 4th turn to throw 1 more bomb and eliminate the boss by eliminating all 3 pillars at once. So basically we have seen that each turn, a bomb can eliminate 1 position until you get down to 3 pillars, at which point 1 bomb is enough to finish the game. So how can we generalize this? We know that after k turns, we'll have eliminated k pillars. And once we have 3 spots left where the boss can be, we'll be able to eliminate them with 1 bomb. So we can eliminate the first n-3 pillars in n-3 turns, and the final 3 pillars can be eliminated in 1 turn. Therefore, we can eliminate all n pillars in n-3 plus 1 or n-2 turns. Is there any situation where this formula doesn't produce the correct answer? Yes?
Or anything less than 3.
Exactly. Well, for equal to 3, it'll still work. But if you have n equals 2 or n equals 1, then the formula doesn't hold. You'll get a value of 0 or -1 bombs. And that doesn't make any sense. So we just set a hard limit saying that if n is less than or equal to 3, then we use 1 bomb only. So as you can see, our solution is literally just that. If n is greater than 3, the answer is n-2. If n is less than or equal to 3, the answer is 1. And that's all you need to do. This is why it's my favorite problem. It seems like it's complicated at the start. Maybe you're not understanding exactly what you're supposed to be doing. And then you start working through some examples and you see that it really boils down to a really simple concept. So this is a great example of a problem where working through on pencil and paper would often aid you more than trying to code a solution. Because if you went through examples, you can see that the coding solution actually isn't all that hard. Really just the hard part was figuring out how to get here. And that is our last example problem for the workshop. So if you guys could click this link and fill out the feedback form, it's literally just a couple multiple choices, super quick, with a spot for longer feedback if you want to give it. We really appreciate that. Just go to that tiny URL link or click on the slides. And we also have a link to the beginner track ICPC Discord page. So if you're not yet on the ACM Discord channel, go ahead and click the link and you can join and you can get taken directly to beginner tracks channel on ACM Discord. And thank you. Thank you guys so much for showing up today. Come back next week for intro to graph theory and apply to be an intern by Friday. Also, we're going to stick around for the next hour and you guys can work on the rest of the problems in the contest. We can help you out with answers. But if you need to leave for anything right now, that's totally okay. And here's the link for the contest, which I'm sure you guys all are already on.
If anyone has questions, feel free to ask anything.
So you guys are free to work on the rest of the problems. Just open up anyone you think sounds interesting. I tried to arrange them in order of roughly ascending difficulty. So if you go to problem D and E, those should be relatively on the same level as the example problems, with the last problem, the contest being a little bit more tricky, but definitely rewarding, definitely worth doing. And also, the more that you participate in contests this quarter, the more likely you are to win a prize at the end of the quarter. Oh, thank you. Thank you. Awesome. Cool. Yes. Start recording.